sometimes you might want to do u-substitution more than once. Imagine that you've got something just really terrible looking, like trying to find an antiderivative of this, -2 cosine x sine x cosine squared x plus 1 dx, right? Can we find an antiderivative of this? We can. You might be thinking, oh, if I could just get rid of that cosine squared term. Well, to do that, let's set u equal to cosine x. Well, let's write that down. So the substitution that I'm proposing is u equals cosine x. And that'll be good because I've got a cosine x and a cosine squared x here, and I can also see du in this integrand, right? What's du? Well, it's the differential of u. What's the derivative of cosine? It's minus sine. So the differential then includes this dx, right? Du is negative sine x dx. Well, let's make the substitution. Let's see how it works out. So this antiderivative problem is now, well, the minus sine x dx will become the du, but I'm left with a 2. Cosine x is u. The minus the 2 and the sine x and the dx, right, are going to be in the du. But I've got a cosine. Cosine squared x is u squared, right, plus 1. And then everything that's left over is in this du. Now I'll make another substitution. I'll make v equal u squared plus 1. Well, let's write that down. So the substitution that I'm proposing is v equals u squared plus 1. And that's a good choice because I've got a u squared plus 1 there, and I can see that the derivative of this appears here. So this will grab quite a bit of the integrand. Okay, let's write down the differential. dv in that case is the derivative 2u du. So dv is 2u du, and now I can write down what this antidifferentiation problem becomes. 2u du ends up being the dv, and I've got a cosine of just v now. Now I can antidifferentiate that, no problem. Right, the antiderivative of cosine v dv is just sine v, and I'll write plus c, right, because the derivative of sine v is cosine v with respect to v. But probably the grader is not going to be too impressed with me if I express my answer in terms of a substitution that I just made up, right? I shouldn't write down the answer in terms of v, I should be writing down the answer in terms of x. I remember from before that v is u squared plus 1, so I can substitute that in here, and instead of writing down sine of v plus c, I'll write down sine of u squared plus 1, and then I'll include that plus c. My answer is in terms of u, but the original question was in terms of x. Let's remember what u was. U was cosine x, so I can make that final substitution back in here. So instead of writing sine of u squared plus 1, I'll write down sine of cosine squared x, because u is cosine x, plus 1 plus c. So what am I claiming? The original question was asking for an antiderivative of this crazy expression, and what I'm claiming then is that the antiderivative of this is sine of cosine squared x plus 1 plus c. So we did it, and I bet that you can imagine some truly terrible antidifferentiation problems that involve substitutions within substitutions within substitutions. Part of the problem with this calculus course, I suppose with calculus courses generally, is that the courses are sort of based on this idea of the instructor just providing problems to you. Here's the challenge. Invent some difficult antiderivative problems for yourself. By cooking up your own antidifferentiation problems, you'll gain some insight into what makes antidifferentiation problems easy and what makes antidifferentiation problems hard.